Hello students. So in today's lecture we are going to understand the numericals which are solved in NCERT textbook. Chapter 10 Light. Let us see the example 10.1. So as usual I'll read the question twice. A convex mirror used for rear view on an automobile has a radius of curvature of 3.00 meters. If a bus is located at 5.00 meters from this mirror, find the position, nature and size of the image. So once when you read, you get some idea about the question, but when you read it second time, you should write what is given and what you have to find out. A convex mirror. So given in the solution, you should write given convex mirror. Used for rear view on an automobile has a radius of curvature of 3.00 meters. So radius of curvature, that is capital R, is 3.00 meters. I have put the plus sign because it is a convex mirror for which radius of curvature and also the focal length is positive. If a bus is located at 5.00 meter from this mirror, so bus is an object here. So object distance U is minus 5.00 meters because as per sign convention U has to be taken as negative and here are positive. Find the position, nature and size of the image. This you have to find out. So after reading the question twice, we should be able to write what is given and what we have to find out. Position means image distance. V you have to find out. Nature. Nature, I feel the best way to find out the nature is to find the M, magnification. And we know when M is positive, nature will be virtual and erect. When M is negative, nature will be real and inverted. So this is one of the very straightforward way. Size of the image we represent it by H dash. So these things we have to find out. Now both are in meters, so no conversion of units is required. R is given. We know that we are considering the mirrors having smaller apertures and for that F is equal to R by 2. Even if it is not mentioned, we have to accept that they are having smaller apertures. So focal length F is R by 2 is equal to R, put the value of R and just simplify it. You get the answer for focal length plus 1.50 meters. Why we have found F? Because we know that using the mirror formula, if we want to find V, we should know F. And F is not given directly here, it is R is given. So now using the mirror formula, 1 upon F is equal to 1 upon V plus 1 upon U. In mirror formula, we have plus here. So from here, take 1 upon U on the other side, we get 1 upon V is equal to 1 upon F minus 1 upon U. Now put the values of F and U and after simplifying, we will get the answer of 1 upon V as 13 upon 15. So V will be equal to, some students do the mistake, they just write 1 upon V is 13 upon 15. Therefore V is equal to 13 upon 15. They do the mistake here. You have to take the reciprocal. V is equal to 15 by 13. Get the answer in 3 decimal places, 1.153. Round it off to 2 decimal places and using the rules for rounding off this number, it is plus 1.15 meters as this 3 is less than 5. Now I have put plus here because in the answer we have to use a convention and give the proper sign. V is positive, okay? So position of image, because the question is what is the position of the image? V is the image distance, 1.15 meter. So position of image is 1.15 meter behind the mirror. We know that virtual image is formed behind the mirror and in case of convex mirror, it is plus sign. Plus sign means if we use a convention, plus is the distance is measured behind the mirror towards the right hand side. So position of image is 1.15 meter behind the mirror. We have done this part. Next is nature. To find the nature, best way is to find the magnification. Now M magnification for mirrors is equal to minus V upon U. Remember, here we have positive and in the magnification formula for mirrors we have minus V upon U. Now put the values of V and U. Now instead of putting V as 1.15, I have chosen this value. V is 15 upon 30. Why? Because this is easier. This will make my calculation easier there. So minus V. V is already positive, 15 upon 30. Upon U, U is minus 5. So after doing the calculation, minus minus gets cancelled. And the answer, when we round it off to 2 decimal places, magnification is plus 0.23. As I have already told you before, when you write the answer, you put the proper sign, whether it is plus or minus. So as M is positive, we know that image is virtual and erect. So we have found the nature of image, it is virtual and erect. Now size of image. Size of object is not given. So we cannot find out the exact size of image, but at least we can give some idea that how enlarged or how diminished it is with respect to size of object from magnification. So let us see how we can do it. Now magnification is equal to h dash upon h. This is a basic formula for magnification. And we have just found magnification is plus 0.23. So from here h dash is equal to 0.23 into h. It means size of image is 0.23 times the size of object. Image is diminished. So we have found the position, nature and size of image. Hope you have understood this numerical. Just do remember that you should write the proper units. Using convention, you should put the proper sign. And in this case position, you should mention whether the image is lying in front of the mirror or behind the mirror. If height of object would have been given, then we are supposed to find the exact height of image. But in this case, we'll just write it is how many times the size of object. Okay? Now example 10.2. An object 4 cm in size, 4.0 cm in size, is placed at 25.0 cm in front of a concave mirror of focal length 15.0 cm. At what distance from the mirror should a screen be placed in order to obtain a sharp image? Find the nature and size of the image. Now, an object 4 cm in size is placed at 25 cm in front of a concave mirror. So we should first write given it is concave mirror. What is the size of object they have given? 4 cm. So h is size or height of object, that is 4.0 cm. Is placed at 25.0 cm in front of the mirror. So object distance u is 25.0 cm, and as per convention we have to take u negative. Of focal length 15.0 cm. So focal length small f is 15.0 cm, but because it is concave, so as per sign convention we have to put negative sign here. U is always negative for all mirrors, f is positive for convex mirror and negative for concave mirror. What we have to find out is, instead of saying find the position of the image, they have said at what distance from the mirror should a screen be placed in order to obtain a sharp image. So indirectly they have asked us to find the image distance, because what will be the image distance will be the same where the screen should be placed in order to get the image. And also find the nature and size. So you have to find V, you have to find nature and size of image. And as I have told you, we'll always prefer for nature we will find magnification M, and for size of image means h dash we have to find. Now using the mirror formula, 1 upon f is 1 upon v plus 1 upon u. We have to find v, so 1 upon v is equal to 1 upon f, take this on the other side, minus 1 upon u. 1 upon v is equal to, put the value of f and u and just simplify it. Take care of this sign, take it up and minus minus is positive. And now take the LCM. You get the answer here, 1 upon v is minus 2 upon 75. But now be careful, v is minus 75 upon 2 and the answer is minus 37.5 meters. Now this is the image distance, but we will write the answer the way they have asked us the question, in that way only. What was the question? At what distance from the mirror should a screen be placed in order to obtain a sharp image? So the screen should be placed at distance 37.5 meter from the mirror in front of it to get a sharp image. We already know, students, that this image is formed. Here this image is formed in front of the mirror because it is negative. Okay. Find the nature and size of the image. So for nature, small m, and what is the formula for mirrors? Minus v upon u. M is minus v upon u. Again, I'll prefer to take v value as minus 75 upon 2 instead of this, because it will make my calculations easier. And putting the value of v as minus 75 upon 2. See, minus is outside also because m is minus v upon u. So let minus be there. Put in the bracket value of v, which is again negative, and divided by u, which is also negative. So in the numerator here, if we do the calculation of this minus signs, so minus becomes plus, and plus and minus in the denominator, it makes minus. So just see, the answer overall comes minus, and after simplifying, the answer is minus 1.5. And since m is negative, the image is real and inverted. So we have found the nature also. Now for size of image, we'll again use a magnification basic formula, that is h dash upon h is equal to m. Now we have found m is minus 1.5. Therefore h dash is minus 1.5 into h. But in this case, we'll not write just the approximate measurement, how many times the size of object do we have the size of image, because in this case height of object is given. So we'll put the value of h therefore, and we get the answer of h dash as minus 6 meter. So height of image is minus 6 meters. This is the numerical which is similar to the previous one, but the only difference is here height of object is given. So you have to find the exact height of image, and instead of asking position, they have put the question in a different form, but indirectly it means you have to find v only. I hope it is clear. Take care of the sign convention. Now example 10.3. A concave lens has focal length of 15 cm. At what distance should the object from the lens be placed so that it forms an image at 10 cm from the lens? Also find the magnification produced by the lens. I'll read it once again. A concave lens. So what is given here? Concave lens. Of focal length 15 cm. So small f is 15 cm. But as per convention for concave lens, focal length is negative. So it has to be minus 15 cm. At what distance should the object from the lens be placed? It means you have to find the object distance u, so that image is formed at 10 cm from the lens. Now v is 10 cm. But students, you have to be very careful. When u is given, u is always negative. When v is given, we have to think about the ray diagrams. You should have the knowledge. Now we know that concave lens always produces virtual and erect images, and they lie in front of the lens. It means the image distance is measured towards the left hand side of origin, optical center. So v has to be negative. So this negative sign you will put only when the properties of images formed by the lenses or mirrors are on your tips. So v is minus 10 cm because the image is virtual and erect. We already know this. Also find the magnification produced by the lens. It means you have to find small m. So we read the question twice. We have written what is given. We have used the proper sign convention, and we have written what we have to find out. Now remember students do one more mistake during the exams or while solving the numericals. They just forget that which formula they have to use. Remember, it is a lens, so you have to use the lens formula only, not the mirror formula. Okay, so 1 upon f is 1 upon v minus 1 upon u. And you have to find u, so take this on the other side. 1 upon u is equal to 1 upon v. Take 1 upon f on the other side, it becomes minus 1 upon f. Now put the value of f and v as given here. And just this will become minus 1 upon 10. This minus minus is plus 1 upon 15. Take the LCM 30. You get the answer of 1 upon u as minus 1 upon 30. So u will be reciprocal of this. So u will be minus 30 centimeter. We can write one sentence here that object should be placed at 30 centimeter in front of the mirror. Okay, this you should write in the form of sentence. Now magnification you have to find out. And magnification formula we cannot use h dash formula, h dash upon h, because they are not given. So we'll use a formula of magnification which is applicable only for lenses, that is m is v upon u. Remember, again I'll remind you, in the lens formula here we have minus sign, and in magnification we don't have minus sign, it is positive. So m is v upon u. Now put the value of v as minus 10 and u as minus 30, and we get the answer of m as 1 upon 3, and the answer with when we round it off to 2 decimal places and when we get the answer in decimals, we get it to be plus 0.33. m is plus 0.33. So these two things were asked, so we have done till here. But if they would have asked find the nature of image, then we would have written here that as m is positive, image is virtual and erect. But no need here because they haven't asked us. Hope this is clear. Now example 10.4. A 2 centimeter tall object, 2.0 they have written, a 2.0 centimeter tall object is placed perpendicular to the principal axis of a convex lens of focal length 10 centimeter. The distance of the object from the lens is 15 centimeter. Find the nature, position and size of the image. Also find its magnification. A 2 centimeter tall object. So given, we'll leave the space here. Height of object is 2.0 centimeter. Is placed perpendicular to the principal axis of a convex lens. So we should write here that it is convex lens. We should always prefer given. In front of given we write what it is. Okay. Height of object is given. It is a convex lens. And they have mentioned it is having focal length 10 centimeter. I have put the plus sign because convex lens has always positive focal length. You can also put positive sign here because height of, as per convention, it is positive. I am not putting because usually it is always positive. Okay. Then find the distance of the object from the lens. So object distance is minus 15 centimeter. They have given the distance of object is 15 centimeter, but we'll use a convention and put the negative sign here. We have to find nature, position and size of the image. Also find its magnification. But as I have told you, for nature we will otherwise also we were going to find m, position means v, size of image means h dash. I hope the question is clear to you and you should be able to write what is given properly with proper signs. Now use the lens formula, as it is a lens. Using the lens formula, 1 upon f is 1 upon v minus 1 upon u. We have to find v. So 1 upon v is equal to 1 upon f. Take this on the other side, plus 1 upon u. Now putting the value of f and u with proper signs, and after doing simplifying, here we get the final answer of 1 upon v as 1 upon 30. Therefore, v is a reciprocal of this. It is plus 30 centimeters. Plus, so what type of image it is? Just guess. Convex lens and plus 30. Okay. So, this image is formed behind the lens and hence this distance is positive. Now, magnification. Magnification we are going to find because we have to find the nature. So, magnification m is v upon u. I'm putting the value of v as plus 30 and u as minus 15. We get the answer for magnification as minus 2. Now as M is negative, so nature of images, it is real and inverted. Okay, so we have found nature, we have found position. Now size of image. So for this we'll use the formula of magnification. M is h dash upon h, and that is equal to -2 as we have calculated it just now. So h dash is -2 into h, -2 into 2, -4 centimeter. So height of image is 4 centimeter. Minus indicates that it is inverted, it is lying below the principal axis. And we know that this inverted image is always real. So we here note down so many things, and I'll summarize this thing in the form of one topic, that is difference between real and inverted images. See, we have done 4 numericals. You have seen that whenever the image is inverted, height is, see, negative. Image is real and inverted. When the height of image is positive, image is virtual and erect. Okay? I hope this is clear to you. And actually for nature, it is not always necessary to find M. But the best method is to find M. Why? Because it is easier for you. M is positive, it is virtual and erect. M is negative, it is real and inverted. Some students who have these properties of images on their tips, they can even write here that in convex lens, as image distance is positive, an image is formed behind the lens. And real image is formed behind the lens, therefore the image is real. But some students may get confused, so the best way to find out the nature is by finding the value of M or sign of M. I hope it is clear. Yes, one very important question which we have left out while doing the theory, although we have discussed it, but we never had put this in the form of question and answer. That is, difference between the real image and virtual image, or real images and virtual images. You must be knowing now all the differences. Let us put this in the form of points here. First of all, always difference should be written in this way, by making the, dividing the page into 2 halves and then writing this way. Some students, they write the differences like this: real image 1, 2, 3, virtual image 1, 2, 3. That is a wrong method of writing the differences. Now real image. Real image is formed when the rays incident from an object or any point actually meet after reflection or refraction. Because images are formed due to reflection also, as in case of mirror, and due to refraction also, as in case of transparent media like glass or water or lenses. Okay, so here real image, when it is formed, when the rays coming from the object actually meet after reflection or refraction. On the other hand, virtual image is formed when the rays incident from an object or point appear to meet. They do not actually meet. They appear to meet after reflection or refraction. And in the ray diagram, whenever real image is formed, solid lines meet and we get the image. In case of virtual image, always we produce the lines backwards, the rays backwards, using dotted lines, and hence the virtual image is formed. Okay? So real image is formed when the solid lines meet, virtual image is formed when the dotted lines meet, but do not mention the difference in this way. Just remember that. This is the proper difference. Second, real image is always inverted. Virtual image is always erect, as we have seen while drawing the ray diagrams, while doing the numericals also. Okay. Third point is, real image can be obtained on the screen. For example, when we take a concave mirror and place in front of sun and place a page in front of the concave mirror, that is, page is lying between sun and the mirror, then sun's image can be formed on the page by changing the distance between the paper and the mirror. Okay, and then it starts burning. So that is actually the real image of sun, which is formed on the paper, which is acting like a screen. So real image can be obtained on the screen. But virtual image, like in case of plane mirror, I have told you, we see our image in the mirror. We see that our image lies behind the mirror. at the same distance from the mirror as we are in front of it. But if we keep the white sheet or any screen there, our image will not be obtained on the screen. So virtual images can be seen in the mirrors, but they cannot be obtained on the screen. So I hope these three differences you should know because they are very important. So this question is also important. You should know the differences between real image and virtual image. So with this, students, we have finished the theory of the chapter, and as well as we have done previously the box questions, and now the solved numericals we have tried to understand, and I hope you have understood them very well. So we are left out with now back exercise, which we'll try to finish in our next lecture. Hope you enjoyed the chapter. Please like the videos if you have understood the chapter. Thank you, students.